So we first have to describe the slope of this line. It's positive, negative, 0, undefined, positive. And then we have to calculate it. So if we're counting from this point to this point, what was our slope?
2.
2. It was 4 over 2, which simplifies to 2. Yes. Because we need to simplify always. Number 2 is a solve this for y. How would we do that?
Subtract. I mean, add 2.
2x. If we were solving for x, then we would be moving to y. Okay, so we have 3y equals 2x plus 12. And divide everything by 3. So our final answer is y equals 3. Nick and his friends rented a canoe for 3 hours and paid $45. How much does it cost per hour to rent a canoe? You're going to give me an answer. Before you do that, what do we know here? How much they paid for per hour. So I can say that's some variable cost per hour. And usually when we have something that's a something per something, we're multiplying that to something else. So this would be our cost per hour. We're going to multiply that times the number of hours. And we know our total is 45. How much did they pay per hour?
$15.
Questions on any of those three? On the back, you're writing equation passing through the point that is parallel. So remember that I said the easiest way to do something like this is to start at the point they give us, -4, -1.
Positive.
Yours is positive?
No.
Well, that's
I drew it wrong. If it is parallel, what do we know about the slopes? Same. So our m is going to be 2, so we're going to go up 2 to the right one as many times as we can. Define our y-intercept, which is at. So our new equation would be y equals 2x plus 7. These lines are parallel, they have the same slope, but different y-intercepts. Questions on that one? Like draw it? They would be parallel. Number 5, we have to graph this inequality. Where do we start? -3 on the x to the y. Y. And then our slope is -2, so we can go up 2, left 1, as many times as possible. Or down to right 1, as many times as possible. Would this be a dashed or a solid line?
Solid.
Solid. And would this be shaded above or below?
Above.
Above. So at my y-intercept, I'm going to draw an arrow up and repeat everything over here. Today, we are going to go over our last topic before it's strictly just SL overview on literal equations. We touched on this briefly. Anytime we had to solve an equation that was in standard form and put it back in slope-intercept form. That was literal equations. But now we're going to be solving it where we really don't have any numbers. So it's going to be a little different. So everyone, look for these notes and the papers in front of you. this is just so you kind of understand what literal means. So, like if I ask you what's the difference between these two sentences, it's raining cats and dogs, and it's literally raining cats and dogs, what is the difference?
Oh, literal means it's actually doing that.
So like there would be actual cats and dogs falling from the sky. It's raining cats and dogs. This is just yes, that. These are just more examples of that because when we say literally, we do mean actually, but not actually having someone's time. And then it says the actual definitions. But when we are solving a literal equation, we're solving it like a normal equation, but we're solving to get a variable by itself like normal, but we won't have a numerical answer. We'll solve it and it'll be like y equals ax plus b. And we won't know an answer. We'll just be solving the equation. So, on this page, it talks about the steps on how to solve. So be thinking, how would I solve a normal equation that looks similar to this? But now it's just letters. So there are similar examples to the ones we're going to do, but we are only going to focus on the ones with letters. So starting at number 2, if we have to solve this for h, we're trying to get h by itself, what would we do? Divide not by 8, by g. Because in this case, if I were solving this for x, I would divide both sides by 2, so it's kind of the same thing. So we divide both sides by g. And then what happens is these g's cancel, and I'm just left with 8 on the left side. But on the right, I have both letters, m and g. I don't know what any of those stand for. I just know that this would be my equation for h. What questions do we have on that one?
I would know where how to use it.
If you've got a problem like this, it would say solve this for the specified variable. Solve this equation for h. And you would know this is a literal equation and I'm not going to have an actual answer.
So maybe just like that.
H equals n over, and that would be your answer. If I knew what these values were, then I could make it make more sense, but that's all we're doing. It's weird, because it's just variables. If we're doing example number 4, now we have ax plus b equals c, and we're trying to solve this for x. So let's think about this one that's similar. So subtract b on both sides. Now b and c are not like terms, so we're just moving it. So we have ax equals c minus b.
And then x would equal c minus q over x. Okay.
Yeah. So for this, when you're dividing it to the other side, you can divide it all at once. So we would just have c minus b over x. I have no idea what any of those things are, but I know that this is the equation to find x. If I had values, I could put them each in and then find my x value, but I don't. Questions on that one? Yeah, okay.
So if it were to say solve for a, would we have to take the a out, the x out?
Yes. So we basically do the same steps, subtract b, but instead of dividing a, we divide x. And if you want to see let's say all of these can be solved for different variables. If this says solve this for b, we would subtract ax. If it said, well, those are all the letters, it's already solved for c.
You can subtract. Aren't those two different variables?
You would subtract, but we wouldn't actually combine them. So, like, if I had to solve for, what did I say, b, I would move this to the other side, but it would just be c minus ax.
So ax would be subtracted as 1.
As one entire term, yeah. Kind of like when you're moving like terms, you're moving the entire term, that would be the same thing. Example 5, we see this type of problem all the time, but now we're solving for x instead of y. What would we do first?
Add the y term, each side is 6y. And then you would divide everything by 3.
Add 6y to the other side. And then divide everything by 3. In this case, because we have numbers, we could either divide them separately or together. I'll do both so you see what happens.
X equals 2y over 2y plus 17.
So you could have this, or if you divided it all together, you would just have x equals 6y plus 17 all over 3, and we couldn't simplify that unless we separated it. And if we separated it, we would get this.
Should we separate? Like we know the math.
I will say that it should accept it either way. It
What
should
if it
accept it
doesn't?
either way. I don't know if it will or not, but it should accept it either way, is my thought process. Because there are different ways to answer everything, so I imagine they would have different answers for things. But I also imagine this would be like a multiple choice. That you could either divide it separately or divide it all together. And both answers would technically be right. Other questions on that?
Like, if you were to divide it all together, wouldn't it be 2y plus 7? How do you know the sentence would be? And
If you divide
Why?
it separately,
no, if you divide it together, take out the 2y.
you would have to separate it. So I would have to say this is the same thing as 6y over 3 and 17 over 3. And then that would get this back. Number 7. Now this is the same format of what we were just doing, but now it's all variables. And we have to solve this for c. What would we do first? We have to subtract this entire term. We could do that, but then we also have to move g back and still deal with that. So that would just help us get c by itself. I'd say let's do something else. We divide by c, we have c everywhere.
We multiply by CD to get it to the we're on 8, right? Oh, 1, 7. Never mind.
We're on 7.
Subtract AB.
You really just did. But if we subtract AB, yes, we can do that. So then we have CD equals G minus AB.
And then divide by D.
And this I'm just going to do all at the same time because none of these are like terms. So we have C equals G minus AB all over D. So it'd be similar to what we just did, but there are no numbers, so we can't simplify or anything like that.
A, B, or G.
first, it shouldn't. So you would have to write it like that, then negative AB plus G. So that shouldn't matter. Any other questions on 7? We're going to turn to the next page.
Do you also separate those two?
In this case, doing that wouldn't help us do anything because nothing is our like terms. Make sure you're writing stuff. Because if I separated it, we'd have G over D and AB over D, and that would really yeah, minus AB over D, and that wouldn't really do anything. We're going to start with number 2 on the next page. There are a couple different ways to do this. One, if we're solving for t, and t is in this one, I could get rid of this p first by subtracting. We have a minus p equals p RT. How would I get t by itself?
Dividing everything.
Divide everything at the same time by p and r at the same time.
Minus Q over P. Q.
The other way you could do this, and this goes hand in hand with what you'll see on like Khan Academy, is that you'll see either something like this where you have the same variable in both, or it's going to be in the format that I'm going to write here. If I see p in both of these, I can say that these have p in common, and I can factor out a p. So if I factor out a p, p would come in front. What would be left if I divide p out of both of those? If I'm dividing p out of these two things.
A part.
1 and R2. Okay. So then I would need to still get t by itself. So I would need to divide both sides by p.
Wait, I'm
Yes.
confused. Why didn't we subtract A?
A is already by itself. So if we subtracted A, we just have 0 on the side. We have to move it back. Divide both sides by p. I'm going to start writing over here because I don't have space. We have A over P equals, now that the P is gone, we no longer need the parentheses. So we could then subtract 1. We have A over P minus 1. Now, this is already in fraction form, so before I do anything with the R, I'm going to change how this looks. Because A over P, if I wanted to make this one simplified fraction, I'd have to get common denominators. So this would have to be a P, and this would, I would need to multiply our numerator by P. So this would change to A minus P all over P, since they now have the same denominator. Equals RT. None of you guys need your computers right now, so you can close those, put them away.
How much time? For the A and P divided by P. Why are A and P separated since P is like 2?
Here, since we subtracted first and then divided, we have to separate the fraction in order to do that. And then in that case, because it's P and R and not just P, they wouldn't really simplify. Now, we could get rid of R by dividing. And because it was a fraction and we're dividing by something else, the R is going to end up where P is. So we would end up with the same thing, but solving it would be different. I know that one was harder. And once we finish these, I will go through a Khan Academy one that is similar, so you would see how we would work that. Do we have any questions on that one?
Or if we get the one again?
When you factored out P, we divided both of these by P and 1 and R2 was left. So a lot of the format you're going to get is this, where it's already factored out and you have to solve for something like inside and then deal with that. Or it looks something like this, where you can factor out something. Number 4, if we have to solve this for M, it means we need to get rid of Z. How would we do that?
Multiply times like B.
So some of these are not that bad. Some of these have multiple steps. It just depends. That would be our final answer. There's nothing else for us to do because M is by itself. On this page or the next, look over the questions that are still left. Are there any that you want to go over before we switch gears? I'll circle them first and then we'll do them. Any others? Anyone? Ready? On this page? Aubrey?
Number 5 on
On the next page. Okay. The next on this page.
All of them on my account.
You're not reading them all. So we're going to start with number 3 on this page, the one we're working on. For number 3, if we're solving for f, we need to get it out of parentheses. So we have one of two choices. We can either get rid of the fraction by moving it to c, or distribute it. Doesn't matter, we'll end up getting the same answer either way. If we move it, that would probably be easier. But in order to do that, we have to multiply this entire side by the reciprocal, by 9/5. So that this and this would cancel. But we'd also have to get it over here. So then we have 9/5c. These would cancel. And we'd just be left with f minus 32. This is a conversion between Celsius and Fahrenheit, if anyone was curious.
I knew the answer does that, but like, how many in this packet are actual equations?
Our actual equations, this one I think is, I don't remember for what,
Wait, actually,
just like in general, like this is an actual equation to switch between Celsius and Fahrenheit.
that one is, I think, density mass problem.
There we go. I was like, I knew it was something. Principal equals interest rate and time. That's a real one. Yep, that's for no. It's like not really for this word, but okay. Slope intercept. Scale effect or something, but I don't remember what. And this is reading.
Area of a circle.
Area of a circle. There we go. So some of them, not all of them. Some are just made up. To solve this for f, we would need to do what?
Add
These are not like terms, so you have 9 over 5c plus 32 equals f. Now, if you did it the other way where you distributed first, you'd have a fraction in front of f. You would need to get rid of the constant and then multiply by a reciprocal to get f at exactly the end. So basically, same steps either way. It's just the order in which you choose to do them. Questions on 3.
Why do we have to 5 and 9?
If I multiply this by 5 nines, that would just give me 25 over 81. It would cancel it. So we would use the inverse. So that is 1.
So are we doing it like this?
We're multiplying the entire side, but really we're just multiplying it to this. Because if we multiply it to 32, we basically be distributing, and that's not what we're doing. So really we're just multiplying it to this, but we have to do it to the other side.
You're doing the 5 times?
Yes. For number 6, we have to solve this for b1, or b sub 1. I feel like this is the actual equation for some thing in geometry, but I don't remember what. Parallelogram, something, I don't know. The easiest way to start this is to get rid of this 1/2 by multiplying, kind of like what we just did. So multiply this entire side by 2, reciprocal, and do the same thing over here. And then we could get rid of h by dividing both sides by h. Then our parentheses would drop, and we can easily solve for b1 by subtracting b2. And I'm going to write this 2 separate ways. So 1, you could leave it as just 2a over h minus b2. Or you could make this one combined fraction. But in order to do that, we would need to have the same denominator. So this would have to be h, and I would have to multiply my numerator by h as well. So we have 2a minus, I'm going to write h in front, h, b2 all over h. So either or. One just looks more complex than the other, please. To which part? Okay. Other questions on 6? On the back, going to number 5. This looks complex, but once you do it, you'll realize it's not that bad. And then 8 is similar. Or no, it's area of a circle. The diameter would be 2. Hence the radius of about the same height as that. If we're solving, 5 was the first one here. If we're solving 5 for z, we need to get rid of 2a. So we're going to move that to the other side. None of these are like terms, so we're just going to move it to the other side. You can put it in alphabetic order. If you want a negative 2a plus 3j minus 4x. And then divide everything by 9. And in this case, you could either divide them separately, only one thing would really simplify, or divide it all together. So let's say I divided it all together. It would be z equals negative 2a plus 3j minus 4x all over 9. If you divided it separately, you have z equals negative 2a over 9 plus j over 3 minus 4x over 9. So both work. Okay.
So that would be j over 3 minus this 3j.
Because here it's not separated. We can only simplify if they're separated. If it's not separated, we cannot simplify. Should. I'll say on the test it will. On the SOL it should. I don't know the actual answer to that. But again, these are usually multiple choice questions for that purpose. Okay. Number 7, if we are solving this for r, we need to get rid of pi n squared. Get rid of pi first by dividing. My pi symbol doesn't look like a pi symbol, but pretend it is. And then we would need to get rid of the square. How do we undo something that's squared? Square root. So we would take the square root on both sides. We have the square root of a over pi equals r. Basically, if you're good with solving equations, imagine that, just you're not going to get an actual answer. With these, there's not really a way to check this in Desmos unless you put in numbers for different variables that are not 1 or 2, because those are too close and you could get something that could be the answer. Do you have any questions on literal equations at all in general? Anything specifically? Okay.
If they give us choice, if they give us 2 answers, but one of the simplified choices.
I'm going to say I have not seen that. Usually it's something that is the answer or something completely wrong. I think. Like if it's a more simplified and the same, I would say go with the more simplified, yes. That. It'll be a mixture. So there'll be drag and drop questions, there'll be plot a graph questions, there'll be choose all, matching, multiple choice, all of them. Take out this packet from the other day. So what we are going to do is I'm going to go through and give you the notes pieces of this, give you any notes pieces for the Desmos hacks, and then as we're on whatever objective, if you have questions or wanted to see certain things, we can go over them. And then we'll move on to the next objective. And we'll just keep doing that until we finish this packet. We're not going to finish this packet today, but next class we'll be working more on this also. So for translating, you don't have to write all of these down, write what you want. If you can't see them, I will read them all. So these are just words that would represent these operations and these things. So for addition, we have plus, sum, increase by, more than, and total. Subtraction, we have difference, minus, less than, fewer, less, subtracted from, decrease by, take away. Again, you don't have to write all of those down, but feel free to write whatever you feel like you need. Multiplication, we have product, times, of, twice, double, triple, and you could continue that. Quadruple, I don't know what 5 is, multiply by 6, whatever, all of those. Division, we have quotient, divided, per, half, over, by, separated into. You need them. Grouping symbols. These are words that tell you whatever I say after these words, I'm going to put in parentheses, or these need to go together. The quantity of, absolute value of, or if you see things like difference of, product of, sum of, quotient of. Anything that is an exponent or a radical, you may see words as square root, squared, cubed, to the power of, raised to. And then for equals, equivalent to, results in, the word is, or is the same as. Oh, I think. From the examples in the translating section, 1, 2, 3, or 4, do we need to see any of those? Or had a question on any of those? Want to see the answers to make sure we're correct? Anything? I did just post this on Canvas under the SOL modules, so you'll be able to go and check this also.
What would the dot register?
Quotient of
Quotient.
this division. No, okay, let me rephrase. Quotient would be division. Quotient of would still be division, but it would also fall under the grouping symbols. Quotient of this and this is how that would be phrased. Or to 5 less than the quantity of a number plus 1. So 5 less than, it's going to go at the end. Quantity of, we're putting that in parentheses, of a number plus 1. Those two things go in parentheses, and then we're subtracting 5 outside of that. And then 4 is up there as well. Questions on either of those two? For evaluating and substituting, there are missing things for the Desmos tax. So for A, type in the expression using all caps. So you can use these variables if you put them in capitalized. And click the all button to add the sliders. So type in using all caps, click the all to add the sliders. Part C is set the correct substitution values, and the answer appears. You could really shorten that. Set the correct values, and the answer appears. So translating things is not something you could do in Desmos. That's something you have to know. Evaluating and substituting you could do in Desmos. Does anyone need to see this in Desmos? How that would work or how we would do that? And did we have questions on 5, 6, 7, or 8? Need to see them, want to check our answers, anything like that.
Let me check the answer.
Seven, -23, 1/2, and 30. Notice that there's no work here. That's because this was done in Desmos. What I would suggest is if you didn't do these, don't just write this down. Go back and do it on Desmos yourself. That way you get practice with doing that. And then go back and double check it later. On the next page, you're now in laws of exponents. So for your Desmos tax, I mentioned this before, but this only applies to multiple choice questions. If you type in the expression, okay, so I didn't know this part. I think before I said use different variables, but if you use x and y but make them caps, then this will still work. So basically, these two are the same steps as what you just wrote down. Type in all caps, click all for the sliders. Change the sliders to the different numbers. This can't be 0 or 1. And then type in the answer choices and find the one that matches. And we've talked about that and done that before. Do you need another copy of this? And I'm going to slide this down so you can also see these rules. So the product rule is a to the m times a to the n equals a to the m plus n. Power rule is a to the m in parentheses. Outside of that, raised to the n equals a to the m times n. Quotient rule is a to the m over a to the n equals a to the m minus n.
Are the m's and n's supposed to represent exponents?
Yes. and then your negative exponent rule, a to the negative m equals 1 over a to the m. I think I used x to the a when I wrote mine, but it's the same thing. Do we need to see this Desmos hack in Desmos? Did we have questions on 1, 2, 3, 4, 5, or 6? Hold on 1 second. What were you saying? This one? Yes, times and then 8. So there you go. Because you take this and you flip it, so it's 1 over a, and then raise the m. So we just keep it m. So the m goes with the a. So if this is not a multiple choice question, that means you would need to know how to do it. You could put your answer in afterwards and put in the original and see if your expression matches if you use this. Who is still writing this? Okay. On the next page on polynomials. For this, if there are multiple variables, and again, this only applies if it's a multiple choice question, you can use the Desmos slider hack. So that's putting in tabs and hitting all or clicking all. If there is only one variable, you can type in the expression using lowercase x's and type in each answer choice to find a matching line or curve. So like for number 8 has multiple variables, so you could put all of that in using capital A, capital B, change the variable or change the number slider to something else that's not 0 or 1 and see which one matches. But for like 7, 9, 11, 12, you could put each of those in, but use X, not Y, and it will graph it for you, and you'll be able to see which one matches. Do we want to see any of these on Desmos? And I'm going to repeat this again. Remember that all of these problems can be solved by hand, but you also have Desmos, so use that. If you have your own graphing calculator, you are allowed to bring that. I don't know if they stop you from using Desmos if you bring your own. You just will not be provided a graphing calculator. 13 and Michael.
So it says mostly power.
Yeah, it'll be on the embedded into the test.
Okay.
So for 13, this is one that has multiple variables, so we would need to put this in capitalized. Fraction first. This would be 21 a to the third. This is how we type this, better, faster than I could do this. And you will have a keyboard, so you won't have to rely on this. You could just type it. E to the disk plus 12a squared b squared minus 18 ab over 3ab. So I put everything in caps. I hit select all. And I'm going to change these to other numbers. And I need the number 447.12. So it'll be the graphing Desmos calculator. Now, some of the functionalities sometimes get taken off, but this should still be there. And then I'm going to type in all of the other answer choices and see what we get. 7ab squared. That's not. Try again. 7ab squared plus 4ab minus 6. That's, oh, I put ab squared, that's why. Stop. Stop. No. There we go. I was going to say, because that one should have been the answer. So when I type in that equation with all caps and I hit sliders, and then I put in one of my answer choices, I see that that slider answer is the same, and I know that is my answer. So what did you do? I just moved this to a random number. It doesn't matter what number. If you want, you can do this. And make it do random things. Just pick a random number, it doesn't matter. It's not 0 or 1. Because that can mess things up. Yeah. Because we will get to it. Just not today. Right, did we want to see any others from the polynomials in Desmos? On to the next page. Factoring. So there's a lot going on. So I'm going to read this as you write. A, graph the expression, identify the x-intercept. B, if the x-intercept is an integer, so a number, negative, positive, 0, anything like that, then the factor is the opposite. So if it says -4, your factor would be x plus 4. If the x-intercept is a decimal, you will need to convert to a fraction. If that's an easy decimal like 1.5, you can put that in, convert that to a fraction, and it'll give you the fraction 3/2. Now, we don't write factors like this, but you could start this off to help you do this. So what they do is write it like this, write it as x the opposite. So this was positive, it'd be x minus this, and then they take the denominator and move it in front of x and leave the numerator there. That's not actually how that works, but I'm not going to get into that right now. There is a mathematical way behind that. Just know that for now, you can use that process. And then the factored form of these two would be x plus 4, the opposite of negative 4, and then 2x minus 3. So let you write that down. I'm going to start reading this, and then I'll stop and see who still needs this. If you have a multiple choice question asking for both factors, graph it. Graph the answer choices to find the matching curve. If you have a multiple choice asking for one factor, you're going to graph it. And then grab each answer choice and pick the line that crosses through the x-intercept of the curve. But I'll scroll down so you can write that down in a second. Who's still writing this part down? Okay.
That was more related to the things like
For E.
we learn that field.
It's something you do more so in, well, like we talked about this when you get factors and you set them equal to 0, but working backwards, that's something we wrote in algebra 2. What it really is you set x equal to 3 over 2 and you solve. So you would multiply by 2 and subtract 3 so it's equal to 0 again. So we use this top part. So then that B part of this was graph each answer choice and pick the line that crosses through an x-intercept of the curve.
Oh, okay.
Who's still writing this bottom part? Does anyone need to see any of 18 through 23 in Desmos? Aubrey. 19. So 4x squared plus 7x minus 2. Plus 7x minus 2, is that right? So we're going to graph this. Look at the x-intercepts. One of these is -2, one of these is 0.25. 0.25 we know is 1/4, but if you didn't know that, you can put that in and make it a fraction. So then our two factors, we're going to take this number and make it the opposite, so x plus 2 would be one of our factors. And then the other one, we would take this fraction and make our factor with it. What did I just say with that? The way they have it is usually x minus 1/4, but then we take the denominator and move it to the front. 4x, and then minus 1, because it was already x minus 1/4. If you put x minus 1/4, I believe you would count that wrong. Because it doesn't graph correctly. So as I'm looking at these two, I don't know if you'll be able to change the lines and colors. You might be able to, but I see that these overlap, so those would be my factors. The only issue about doing this in Desmos, factoring like this in Desmos, is that if you have a DCF, it's not going to show up. You have to know to be able to factor out the DCF first and include it in the factored form. Do we want to see any other questions on this page? On the next page. If you have a multiple choice question, you can use the Desmos slider. So we've talked about this. If they're all like just numbers, you could put in square root of whatever, put in your answer choices, see which one matches. If it has variables, you could put in, make sure all the variables are capitalized, and then you could double check and see which one has the same numbers. We have done a question like this where you get two answers that match. You have to look for the one, that's more simplified. Because they will do that a lot. There are two different ways to get your square root and cube root symbols. You can either click on the square root button or click in your functions, click or scroll all the way down and find the nth root to put in your 3, or you can type in these and it'll give you, like that will pop up as soon as you finish typing T. SQRT or CBRT.
And then
You type it in uppercase, I don't know what will happen, but we can try it if you want. Anyone still writing this down? I'll type it in just to see what happens. thinks you want to put in numbers or something for sliders. So yeah, it has to be lowercase. Did we want to see any of these in Desmos? On to the next page. We're now in A4, solving equations. So when you use Desmos, you can type the equation into Desmos using lowercase x's, not y. So if the equation has some other variable, you have to use x. And then you may need to zoom out depending on how big or small it is, and find where that vertical line crosses your x-axis. And that would be your solution. X equals whatever that number is. However, if you keep zooming out and there no line appears, then you have to put both sides in separately. And when you put them in separately, you'll either get parallel lines to mean no solution, or the lines will be on top of one another, and you may be able to change the color or the dotted lines to see if they are both there. And that would mean infinitely many.
Yes, for the platform.
Say that again.
What is the next stack?
One on top of the other. So, like, you may not be able to see that there are two there, but they are both there. Do we want to see any of these examples in Desmos before we switch gears into quadratics? Javier? Number one. After everyone finishes, I'll put number one in. I will say number one is going to give us one solution, and you'll be able to see what that looks like. Okay. Doctor?
And what line is one solution?
One solution?
Yes.
Yeah, one. There will be one line at one solution that crosses the x-axis.
That's what line would be?
Anyone still writing this down? How do you read, or anyone read off that first one for me?
X minus 5. And just parentheses equals.
Okay.
Yeah.
So right now I can't see you, but if I start zooming out, and I don't know if this will be an option for you, but you may want to go into the wrench and click this one just to make everything bigger. But I have some vertical lines. I'm going to change the color so we can all see it. And I would just click on where it crosses the x-axis at 12. X equals 12 would be my answer.
We have to put like what's that is one.
That would be the solution. X equals 12. Because this is just a solving problem, so at the end you get x equals 12. Do you want to see any of the other solving ones before we move on to quadratics? For quadratics, and we talked about this a lot, the x-intercept solutions, roots, zeros, those are all the same thing. They could interchange from one question to the next. Do not be confused by that wording. They all mean the same thing. You're all looking for the same thing. But for your quadratics, you're going to type the expression of the equation into Desmos using lowercase x's. and look for your x and steps. That will tell you your solution, your roots, your zeros. And then at the bottom of this, I believe that you'll be given the quadratic formula. We have not talked about that in here. Yeah. But this is another way to find solutions for zeros or roots. Yes, the quadratic formula was on the formula sheet, so that will be there. Not something you need to memorize. If you put in the equation like this, then you could use the Desmos slider hack. Ooh, my ear. Yes. As soon as possible. Does anyone need this top part? And then we'll scroll down.
You go.
Does anyone want to see any of these questions in Desmos? Does anyone need this bottom part still? Let me let them finish, and then as soon as, because this will be the last week we do for today.
Say that one more time. What situation do you use?
So all of these factoring quadratic formula are all different ways to find your solutions. Quadratic formula is really if you can't do factors, but if you're using Desmos to find your solutions, neither of those really apply. This is if you want to do it like this. So on Friday, remember to have your A7E, A8, and A9 from the SL standards. Those will be the last ones from that packet. We'll go over that. You'll have another shark bite, and we'll continue going through this. If we finish this next class, I'll give you another one. Work through as many of these that you can. Try them on Desmos. The answer keys on Canvas. Come see me if you need help with any of those or want me to check them. If you have not finished your Unit 9 test or need to start retest stuff, come see me after school today or tomorrow. But you guys can put your phones up or put your calculators up and down your phone. So what would happen is you would put in all your values, A, B, and C, and you would start to simplify. And at the end, you would get you would get a plus answer, and you would get a answer.
Okay, go down.
As soon as Kat finishes writing this down.